Welcome to Smart Tech and Biz, where technology and innovation drive the conversation. Today, we're taking you inside the EV battery race, a global competition that's changing how we move, work, and live. From cutting-edge solid-state batteries to next-gen lithium alternatives, this is the tech that could change the world. You know how it is. You get in your car, you turn the key, or these days you push a button and it just goes. For over a century, that magic was all about tiny explosions, gasoline, pistons, fire. It was loud, it was a little bit messy, and it worked. But now, the world is changing. The new magic is silence. It's the smooth, instant hum of an electric motor. Suddenly, the most important part of a car isn't the engine anymore. It's the battery. And this isn't just a small change. It's like swapping out a horse for a rocket ship. The entire game has been flipped on its head, and everyone is scrambling to figure out the new rules. Think about it. The battery is everything now. It dictates how far you can drive before that little pang of range anxiety kicks in. It determines whether you can charge up in the time it takes to grab a coffee, or if you need to pack a lunch and a good book. It's the single most expensive component in an electric vehicle, which means it controls whether you can actually afford one. And let's not forget safety. We want a battery that powers our car, not one that puts on a fireworks display on the highway. This is why the race to build a better battery is one of the most intense, high-stakes competitions on the planet today. This isn't just about making cooler, faster cars, though that's a nice bonus. This is about our wallets and our world. Cheaper batteries shift power from oil to battery nations and unlock a cleaner grid. When you think of electric cars, you probably think of Tesla. And when Tesla thinks about the future, it thinks about manufacturing. Specifically, how to make a ridiculous number of batteries, faster and cheaper than anyone else. This is where their superstar player comes in, the 4680 cell. It sounds like a secret agent's code name, but the numbers are just its dimensions: 46 millimeters wide, 80 millimeters tall. It's basically a bigger, beefier version of the cylindrical cells you'd find in a laptop, but supercharged for a car. The bigger size means fewer cells per pack, simpler manufacturing, and lower costs, like building a wall with big bricks faster. The real genius isn't just size. A tabless design helps manage heat and deliver power more efficiently. This is classic. Practical improvements you can scale. A revolutionary idea is useless if you can't build millions of them. While others hype miracle batteries, Musk focuses on what gigafactories can churn out tomorrow. Scale is the ultimate weapon. So what about solid state? Musk calls it a holy grail that's always a few years away, a great PowerPoint, without a clear path to mass production. Tesla is betting on continuous improvements to today's lithium-ion chemistry, plus 4680 manufacturing breakthroughs to stay ahead. This ties to a bigger goal: a million-mile battery, thousands of cycles with minimal degradation, a long-term asset that slashes ownership costs. Refine what they know, scale it like never before, and drive costs down relentlessly. A pragmatic, manufacturing-first approach in a field full of futuristic promises. While Tesla focuses internally, its major partners, such as Panasonic and CATL, have already started investing in hybrid and semi-solid battery technologies, suggesting an industry-wide trend toward these designs. On the other side of the world, you have Toyota, a company that practically invented the modern, efficient car with the Prius. They seemed late to the all-electric party, preferring hybrids, but they were playing the long game, quietly pouring billions and filing thousands of patents into the future: solid-state batteries, conventional lithium-ion, positive electrode, negative electrode, and a flammable liquid electrolyte in between. Solid state replaces the liquid with a thin, solid material more stable, far less prone to fire. Think water balloon to bowling ball. It can unlock higher energy density, more range in a smaller, lighter package. Toyota talks 700+ miles and 1080% in not sure's 10 minutes. They've teased a manufacturing breakthrough and plans to commercialize soon. Bold claims met with excitement and skepticism. If anyone can turn delicate prototypes into robust mass production, it's Toyota, a manufacturing powerhouse. High risk, high reward. If they succeed, they could leapfrog the industry and redefine the electric car. They see solid state as the tech that finally makes EVs superior to gasoline in every way. The German auto giants, Mercedes-Benz and BMW, are not ones to be left behind. Known for engines and luxury, they're applying the same relentless drive to batteries, but they're collaborating, acting like savvy VCs, partnering to accelerate development. Mercedes has thrown weight behind factorial energy and quasi-solid-state cells. A solid electrolyte with a touch of liquid boosts performance and manufacturability. The hybrid approach promises higher energy density and improved safety without brutal production hurdles. Mercedes is co-developing and road testing toward ranges north of 600 miles. BMW partners with Solid Power on all solid-state using sulfide electrolytes, excellent ion conductivity for power and fast charging. BMW helps stand up a pilot line, learning the tech while tackling the scale-up. Partnerships let them explore many bets at once. Startups handle high-risk science, OEMs bring manufacturing, quality, and supply chain. Goal: future models that remain pinnacles of performance, luxury, and range. While many chase chemistry, Stellantis steps back. What if the battery pack itself was smarter? IBIS Intelligent Battery Integrated System embeds charger and inverter inside the pack. Traditionally, they're bulky boxes elsewhere. Bring them inside the pack to save space and copper. Up to 40 kilograms saved and more usable interior space. Stellantis estimates up to a 10% efficiency gain, more range without changing cells. With the inverter right next to cells, output can jump by roughly 15%, AC charging up to 15% faster, and for second life, because power electronics are inside, repurposing is simpler and cheaper. You essentially have a ready-to-go energy storage unit, better economics for reuse and recycling. A prototype IBIS system has been installed and tested, pointing to a smarter, holistic architecture. While headlines chase solid state and 4680, another revolution is here: LFP lithium iron phosphate. For years, nickel manganese cobalt dominated for energy density, but LFP is back in a big way. No cobalt, no nickel, instead iron and phosphate. Abundant, cheaper inputs that drop battery costs. LFP is exceptionally safe and durable. The chemistry is more stable and far less prone to thermal runaway. It endures thousands of cycles with minimal degradation. You can regularly charge to 100% without the long-term penalty common to many NMC packs. Lower cost, high safety, and long life make LFP ideal for standard range EVs from Tesla, Ford, and others. The battery war isn't one winner takes all, it's about matching chemistry to use case. Expect a diverse mix of chemistries tailored to price points and needs driving mass adoption. All paths converge on the same goals: improving safety, increasing longevity, reducing cost. Safety is non-negotiable. As prices fall toward $100 per kilowatt hour, EVs hit price parity and adoption accelerates. So, who's going to win the great EV battery war? Tesla's manufacturing muscle? 4680 cells? Toyota's solid-state bet? The German giants with startup partnerships? The honest answer? It's complicated. This isn't a single race, it's a decathlon. Winners in high density, low cost, fast charge, safety, longevity. The true winner will be us, drivers, consumers, and the planet. Expect Tesla to scale 4680 and cut costs, Toyota to launch limited high-end solid-state, Mercedes and BMW to show flagships, startups to contribute breakthroughs, affordable LFP to dominate mainstream. This race reshapes our relationship with energy, enabling resilient, sustainable grids. The battery is the key technology of the 21st century. The road is long, but a clean, affordable energy future feels inevitable. That's a wrap on today's deep dive inside the EV battery race. If you want to stay ahead of the curve on tech breakthroughs, business trends, and the future of EVs, you know what to do. Please subscribe, share, and like.